You know that feeling when you can just tell something's off with a friend, but you can't quite put your finger on it? Well, what if a machine could? Today, we're going to dive into how AI is learning to see and hear the really subtle objective signs of mental health conditions. We're talking about clues that are hidden in our language, our voice, and even in our phones. Let's see what it's finding.
Okay, take a look at this number, 227. That's how many different ways a person can meet the diagnostic criteria for major depressive disorder, 227. It just perfectly shows the biggest challenge in psychiatry. For so long, diagnosis has relied on what people tell their doctors, which, as you can imagine, can be really inconsistent.
And that really brings us to the core question here. With that much variation, what if we could find objective, measurable signs for mental health? You know, kind of like how an X-ray can show you a broken bone. What's the mental health equivalent of an X-ray?
For decades, the way we've assessed mental health has been pretty straightforward. It's based on a conversation, a clinical interview, and maybe some questionnaires you fill out yourself. And look, that process is incredibly important, but it's definitely not perfect. I mean, think about it. The way you describe your last month can totally change based on how you feel today. That variability plus our own biases means that sometimes, especially in milder cases, things get missed. Unlike other fields of medicine that have clear biomarkers, psychiatry has been missing those, but that is definitely starting to change. And this is where things get really interesting. This is where AI steps in. AI gives us a way to analyze what researchers are calling observable cues. And that's basically just the gigantic amount of objective data we create every single day, most of the time without even thinking about it.
The key idea here has a pretty cool name, digital phenotyping. All it really means is creating a sort of portrait of your well-being by analyzing the digital breadcrumbs you leave behind with your phone, your smartwatch, you name it. It's a way to monitor things passively in the background all the time.
So what kind of clues are we talking about? Well, they fall into a few big buckets. The words we use, the sound of our voice, our facial expressions, things our body is doing like our heart rate, and our digital behavior, like how much we're moving around or who we're calling. AI is basically built to be a detective, to sift through all this data and connect dots we would never see on our own.
So, theory is great, but what does this actually look like? Let's start with depression, because that's where most of the research has been focused. And it turns out researchers have found a surprisingly consistent digital footprint that's linked to depressive states. First up, let's talk about language. The words we pick, they're like a window into our heads. And AI models that have been trained on tons of text from social media and interviews have found some really clear markers.
The patterns here are just fascinating. The AI analysis shows a big increase in self-focused language, so a lot more I, me, my. It points to that inward focus that's so common in depression. You also see a clear spike in negative words and these absolutist words, like always and never. And on top of all that, the language itself just tends to get a little less complex. But it's not just what we say, right? It's how we say it. Our voice is packed with information about our mood, and AI can pick up on these incredibly subtle changes in how we talk. So the vocal signature of depression, with the AI hears, is often a slower way of talking, more pauses and longer ones. The voice itself becomes flatter, more monotonous, with less variation in pitch and volume. People also just tend to talk less overall. It's the audible sign of something clinicians call psychomotor slowing, where your thoughts and your body just feel sluggish. Okay, so we've got what we say and how we say it. But AI can also analyze what we do. Our day-to-day behaviors, tracked passively by our phones, can paint an even clearer picture of what's going on inside. And this is where you can really see the pattern of withdrawal. The GPS data from a phone often shows that people with depression are going to fewer places, spending a lot more time at home. The phone's accelerometer tracks a drop in physical activity. Sleep patterns get all out of whack. And phone logs show fewer calls being made, which reflects that social withdrawal, even if total screen time might actually go up. Okay, so those signals are pretty distinct for depression. But what about other things? Well, AI is also getting better at telling the difference between the unique signals of anxiety and the really complex patterns of borderline personality disorder, or BPD. With anxiety, the main theme is vigilance. The language used is often about threats and being on guard. But the really big clues are often physiological.
The AI can detect a body that's on high alert. It does this by looking at things like reduced heart rate variability. That's just the variation in time between your heartbeats, which is a classic sign of your body being stuck in fight or flight mode. Behaviorally, that often looks like avoiding certain places or situations.
Now, borderline personality disorder is known for being really complex, and its digital signals absolutely reflect that. Just as the research says, the patterns are way more complicated, and honestly, they often seem to contradict each other.
And this brings up one of the most incredible findings: paradoxical expressions. With BPD, an AI analyzing someone's face might see hostile signals, like contempt, showing up at the exact same time as friendly signals, like a social smile. It's a powerful reflection of that internal conflict and emotional push and pull that's a core feature of the disorder.
So let's just put it all side by side. As you can see, these digital fingerprints are really distinct. With depression, the focus is internal, all about I, and the behavior is withdrawal. With anxiety, the focus is external, all about threats, and the behavior is avoidance. And BPD really stands out with its impersonal language, that emotional ambivalence, and those conflicting social signals.
So what does all this mean for the future of mental health care? The potential is just enormous. But, and this is a really big but, so are the challenges. And here's something really interesting. Some of these cues aren't specific to one diagnosis. They're what you'd call transdiagnostic. For instance, that reduced heart rate variability we mentioned, it shows up in depression, anxiety, and BPD. This suggests it might be a general marker for mental distress, pointing to some shared biology that our current diagnostic boxes don't quite capture.
The promise here is so clear. We could detect problems earlier, we could track symptoms objectively with real data, and we could create treatments that are truly personalized. But all of that has to be weighed against the peril. We have to solve massive issues around data privacy and security, and we have to guard against algorithmic bias, making sure these tools are used responsibly before they ever become widespread. And that really brings us to the final thought. This technology could literally give a voice to suffering that's often completely silent. It could hear the clues when people can't find the words themselves. The question for all of us is, are we ready to build a world where that's possible? And are we ready to do it the right way?